1.9 talks about modeling with functions. It says in real-world settings, we need to construct functions by translating verbal descriptions into language of mathematics. We're learning to assign meaningful variables and symbols that will represent both independent and dependent events. Let's explore some situations where we can create a function or rule that represents real-world events. And so we can see here we have example 1. It says writing functions from formulas. It tells us the perimeter of a rectangular garden is 84 feet. Express its area A as a function of the width W of a side. Alright, so they told us about the perimeter. Well, what do we know about perimeter of a rectangle? Well, remember, the perimeter is all the sides added together, so it's 2L plus 2W. And they told us that the perimeter was 84. So we know that really this means that 84 is equal to 2 times L plus 2 times W. Now, it also told us it wants us to express the area as a function of the width W. When it says as a function of the width W, it's like, and the variable is going to be W, okay? So, what do we know about area of a rectangle? Well, we know area is equal to length times width. But it wants area as a function of the widths, meaning the W, the width, is the only variable we can have. So we've got to somehow get rid of that length. Well, that's where this other equation comes in play. If we can solve this perimeter equation for L, then we can substitute it into the area function. Alright, so let's solve this equation on the left here, the perimeter one for L. So I'm going to subtract my 2W. And so I got 84 minus 2W equals 2L. And then we can divide everything here by 2. And so when we do that, we get L equals 84 divided by 2 is 42 minus, and 2W divided by 2 is just W. So we know that L is equal to 42 minus W. Well, now that we know that, we can take that and we can plug it into this equation. So the area is equal to the length, which is 42 minus W, times W. And then we can distribute the W, and we end up with 42W minus W squared. And so we found the area as a function of the width. Okay, example 2. So the volume of a right circular cone is V equals 1/3 pi r squared h. If the height is twice the radius, A says express the volume V as a function of the radius r. So we want the volume as a function of the radius r, meaning volume where radius, the r, is the only variable we've got in it. Well, let's see. They gave us the equation, so we know that V is equal to 1/3 pi r squared h. So that means we've got to get rid of that h somehow. Well, it tells us over here the height is, so height is twice, 2 times the radius, r. So my height is equal to 2r. So I can substitute that in over here. So we got 1/3 pi r squared times 2r. Well, then I'm just going to simplify this. So let's see, I'll put my numbers at the front. So this is 1/3 times 2 over 1. Remember, you multiply a fraction straight across, so we get 2/3 pi r cubed when I multiply my r squared times my r. And so that's simplified, so I can leave it like that. Or sometimes, since pi is a number as well, they'll put it over 1, and sometimes you could see it written as 2 pi over 3 and then r cubed. Doesn't matter, same equation. Alright, then it wants us to find the volume of a paper snow cone cup whose radius is 2 inches. Well, we know the radius is 2 inches, so we can plug it into the formula that we just created. It's V equals 2/3 pi times 2 cubed. Alright, and let's put that in our calculator and let's see what we come up with. Alright, so when I put this in my calculator, I ended up with 16.755 when I round to the third decimal place. So 16.755. It's okay on the word problems to round. We like exact answers except when it's word problems. This makes more sense to us when it's a rounded number versus an exact number. Alright, so make sure if you're going to round to 3 decimal places and make sure you label. Okay, volume, we know it's going to be in the inches from the problem, and volume is always in cubic units. And so there is our answer. Okay, moving on to business and economics. It says, in the business world, we are concerned with sales, cost, revenue, consumer demands, and profit. Revenue R is defined as the money received for the sale of X units sold at the retail price of P. That is, R is equal to P times X. The law of demand from economics tells us that the price and units sold are related. Specifically, as one increases, the other decreases. So in example 3 here, it says the demand for tickets to a local water park is given by P is equal to 75 minus 0.02x, where P is the price of a ticket in dollars and X is the number of people going to the park at that price. A says what price would provide an attendance of 3,000 people. Alright, so they gave us an equation. It says the demand for the tickets is given by P is equal to that equation, where P is the price of the ticket in dollars and X is the number of people. So this 3,000 is going to be our number of people. So we know then that X is equal to 3,000, and we can plug it in to find the price P. Alright, so P is equal to 75 minus 0.02 times 3,000. And we should get 15. And we're talking about price, and it's in dollars. So $15. It says, what is the total revenue at this ticket price? Well, remember that revenue is equal to the price times the total number. So revenue here would be the 15 times the 3,000. And so we should get 45,000. And remember, it's in dollars. And C says, write the revenue function as a function of the attendance X at the water park. So we just want the equation here now that we can use. So we know that revenue is equal to P, which P was 75 minus 0.02x times X. So just distribute the X, and we end up with R is equal to 75x minus 0.02x squared. Okay, in example 4, it said a skateboard designer has fixed monthly costs of $9,202 and variable costs of $18 for each skateboard produced. The skateboards sell for $125 each. How many skateboards should the designer produce and sell each month to break even? What is the total revenue at the point where the designer breaks even? Alright, so what does it mean to break even? That's where our cost is equal. It's where the cost is equal to the revenue. Alright, well, let's see what we know about these. So I'm going to come over here on the side and let's talk about the cost. Well, the cost, it says, is a fixed monthly cost of $9,202 plus is a variable cost of $18 for each skateboard. The revenue is, remember, the price times however many. So it says the skateboards will sell for $125 each. So that's just the revenue is 125x. So if I want to find that break-even point, I'm going to set those two equal. So 9,202 plus 18x is going to equal 125x. And so let's solve for x. So 9202 divided by 107. And so X is equal to 86 skateboards. So when he sells 86 skateboards, he will break even. Now, it says, what is the total revenue at the point where the designer breaks even? Well, then we're going to take that and plug it into our revenue. So our revenue is equal to 125 times that 86. And so that's going to be $10,750.